what does it tell about this data set? Okay, so essentially the correlation coefficient will calculate something between 0 and 1.
Yeah, but okay, never mind.
Okay, what?
Exception unhandled says don't edit it, it takes too long. Yeah, but then it's like 4 hours.
Not really. We're not going to do too much tonight, because we're going to revise tomorrow. Yeah, obviously. To be honest, I wouldn't be surprised if that was actually cause. I think he would do kind of, I'm not sure.
Yeah, but why would he say he's Carlos's dad?
Duh. To make it funny.
Cos is your dad.
No.
Is that what you're trying to tell us, Carlos?
No. Okay, so correlation coefficient calculates the value from 0 to 1. So, if it's 0, then there's no correlation. If it's 1, then it's perfect correlation.
And if it's -1? Oh, did I freak you?
No, I'm trying to type. I mean to write down with, you know.
Like, you know.
Yeah, I know. But you'll see when I try to spell perfect correlation, I kind of struggle.
No correlation. Wow. Wow. Is that even eligible?
I don't know. Okay, so what can I say about it? Let's make this a bit tiny, 12 pixels. Okay, so because we get 0.9888, and that's just 0.02 something, 1, 2. I don't even know. What's that? 1 minus 0.9888 is 0.112 difference from 1. That means it's a pretty good correlation. So it's a very... Oh, that's really tiny. Cool. So it's very tiny correlation, very high degree of correlation, and it could be said to be this is really hard to type, and it could be said to be to follow a linear trend. I'm just copying what God said, kind of. Yeah. But we can see that, like, if you look at the graph, you can see the dots almost touch the line. That means it will follow linear. So yeah, that's basically what it does. And I just realized I missed one part of part B.
Yeah.
So I'll come back to it in a bit. So what else can we say? Okay, does it go with extrapolation and interpolation? Okay, interpolation does work because we were meant to try it on part B, but we didn't. But with extrapolation, so values outside the x, it should not work because we change. We don't really get taller as we get older. So yeah, it shouldn't work with extrapolation. I would say that. But yeah, for now let's just skip this. And let's do part B with 27. I forgot to do that. So B again. So this was C. This is B part 2. BII. Something like that. Okay, so we have to find the value when x equals to 27. So this is simple. You just put the value of 27 in x. So you find the formula there. So 0. Okay, this formula here. I'm not even sure which layer that is anymore. So yeah, you just basically just put 27 where the x is. So as a general form, you'll have the b1 value and then x. So you put 27 where the x is, and then you just do the calculation, and you'll find out that the y would be 82.1 rounded to 1 decimal place. And then you just type your answer as 27-year-old is on average 82.1. So yeah, I think we do have a value for 27. So 27 would be 81.8. So it's not that off. I mean, it's quite close to the value that we get in the first place. But yeah, this is regression done. So we've done regression. If you have any questions for regression, just say it, so we can go to the next one that I'm not very confident with. Newton-Raphson Method. Okay, where is that?
Time for Newton-Raphson.
Yeah. Are we having a break today or something?
Should we have one after the second, after Newton-Raphson then?
Okay.
Or do you want to go straight into?
Can I go to the next part?
I think so. I don't think anyone's debating.
Yeah, I need to go and order my food.
Do you want to have a break now then?
That won't take long to order the food.
Okay, just do it now then. On stream. Guys, input. What should Carlos have for dinner?
Well,
Tell us now.
I'm kidding. I'm not gonna do it. Let's just create a new thing. So
I need to put a new battery. What happened to Carlos's dad?
I don't know what the hell it might add. I think he swore too much. I'm kidding, I banned him.
Wow.
You can see it on the stream, I banned him.
Yeah, I just saw it bang. Just looking at you like,
Go away.
Huh?
I need my food. I don't even know who he is.
Carlos would die, and it would be sad for him.
Okay, so we just start with Newton-Raphson then.
Yeah.
So Newton-Raphson. So Newton-Raphson method. Let's start. So one of the things we need to know is how to find the new approximation. So this is how to do it. So it's x new equals to the previous value of x minus the function of the previous value of x divided by the differentiation of that function with the value of x. So that made no sense, did it?
It will make sense.
It does make sense. You just need to relax first and try to understand.
This is a bit I don't understand, so I need to understand.
So to the Newton-Raphson, I'm going to get a question from somewhere.
I sent you that, the one of the questions, haven't I?
Oh, yeah, I do have something. Let's do that.
My son. I am. What? They made another account.
Tell us who you are, and then we'll discuss. And his name is not Constantine; it's Constantinus.
Wow.
What are we gonna do now?
Yeah.
What happened? Well, okay, so Nathan had to mute his mic, that's why it's so silent now.
I forgot I muted my mic as well.
Yes, I know you did.
Awkward. I've been talking for the last 5 minutes.
No, that was a fail. Okay, so this is another thing that's important for Newton-Raphson. What it actually does. So Newton-Raphson calculates approximations with tangents. So tangents are lines that only touch the curve at one specific point. So this would be a tangent.
Hello.
Not quite precise, but yeah. Hi, Nathan. So yeah, the tangent was just crossed.
The guy that's your father and Constantine obviously knows who I am.
Of course, Cos knows who you are. Who he is.
What, my Skype? What, my Skype?
It's probably Matt.
Oh, your Skype.
It's either Matt or Ashley.
No, Ashley's exception and handle.
Uh.
So this will be a tangent.
Got figured out.
I'm not sure though. I'm kidding.
Go away, Dan.
I'm just guessing stuff. Okay, so that's what it does. It calculates tangents to find the new approximation. And yeah, that's it. So I'm gonna get a question from the things. Probably the question number 1 from the tutorial. Don't blame me if it's not correct. Just come tomorrow and we can work it out together.
Actually, don't come, please. I don't like you. You got us to 22 followers.
Try catch. But What did you say, Nathan?
What?
What did you say?
I don't like these people that have followed us.
Who followed us?
We've got 22 followers.
Oh, yeah.
Yeah. Okay, let's do the what.
Okay, so this is the question we're given. It's different from the one in the revision because in the revision questions we get a criteria to stop. That is essentially if something is minus that and the value is less than 0.01, then you stop. But on this one, we get that we should stop when the function. So we should stop when the function of x is less than that value there. So this is when to stop. And again, I'm going to use Excel for this because I'm lazy and we don't want to spend too much time on this. So yeah, let's make this a bit bigger.
Yeah, Ashley does that face all the time.
Yeah, got it right.
Well, might be. Wait.
Okay, so I'm gonna cut out some parts of this question actually, because it says